In this video series, we're going to focus on significant figures in calculations. So the first type of rules that we look at as review are multiplication and division. So just remember that the rule for multiplication and division is that we want to round our final answer to the same number of digits as the number with the fewest significant figures out of the numbers that we use in the calculation. So in the example shown here to the left, we have 4 significant figures in the first number, right? 5 significant figures in the second number. And then in our answer, we're going to reduce it down to 4 significant figures. So remember that trick where we start at the leftmost non-zero digit, which is the 4, and then trace until we get 4. So we get to the next non-zero digit that's 4 out. And then look next to the 4 and decide if we're going to round up or down. And in this case, we round down. So you get 4,094 is rounded to 4 sig figs. Okay, so let's do some practice with this. We're going to perform each of the calculations and round the final answer to the correct number of sig figs. So first we need to decide how many sig figs that we have in each number listed. And remember, with scientific notation, we're only focused on that coefficient. Okay, so if we look at the coefficient in our first number, we see that all 3 digits are significant, no zeros to worry about, and so we get 3 sig figs. And then in the second number, again, only focusing on that coefficient, we have 2 non-zero digits, and so we have 2 sig figs. Okay, so if we want to round our answer, we need to round it to the least number of sig figs of the 2 numbers that we used. And that means that our answer should end in 2 sig figs. Okay, so in the calculator, depending on how your calculator shows, whether it's in standard or scientific, it should come out to be 4,166,200. Okay, in standard notation. Now, if we want to convert that into scientific notation, we're going to bring that decimal 6 places over. Remember, you only want to have 1 non-zero digit to the left of your new decimal place. So that's going to be 4.1662. We're going to drop those zeros because we know we need to end with 2 sig figs at the end. And that's times 10 to the 6th. It is a positive 6 because this is a large number. Okay, now we need to round to 2 sig figs. So, starting at the leftmost non-zero digit, that 4 and that 1 will be our 2 sig figs. Again, coefficient's all that matters. Look to the right of that 1, and we decide to round the 1 up to a 2. So we end with 4.2. and then times 10 to the 6th. Of course, you've got to keep the times 10 power because you have to keep the magnitude. Remember, there is a difference between whether a digit is significant and whether it's important for magnitude. Okay, and so that 10 to the 6th is still important for our magnitude. Okay, let's look at the second example. So in the second example, starting with that top number, remember, is that 0 significant? And it's based on, is it after a non-zero digit number, which it is, it comes after that 8, and there is a decimal present, doesn't matter where it is, and so yes, that 0 is significant. Okay, so we do have 3 sig figs in our top number. And then underneath, all of those are non-zero, so all of them are significant, and we get 4 sig figs. Okay. So using the least, our final answer needs to be rounded to 3 significant figures. So in the calculator, it should come out to be 2.077, and the number may continue. If we need this rounded to 3 significant figures, we're going to include the 2, the 0, and the 7. Remember, that 0 is significant because it's sandwiched. And then we're going to look to the right of that 7 and realize that we need to round up to 2.08. Okay, so the next set of rules that we have are addition and subtraction. And in addition and subtraction, I think this is the harder of the two rules. We need to have the fewest decimal places, or the number that ends in the highest place value. Okay, so there may or may not be a decimal place, and if it ends in significance at the tens place and everything else ends in the ones place, your final answer would come out to the tens place. So in the example that we have shown here, the top number is out to the 10,000ths place. That's where the significance stops, because all of those digits are significant and we're looking at the last significant digit in the number. Okay, and then in the second number below it, it goes out to the thousandths place and then stops in significance. So our final answer needs to end with the highest place value that ends in significance, which is that second number at the thousandths place. Okay, so the best way to do questions like this with addition and subtraction is to go back to that vertical mathematical operation like what you may have saw when we were younger in elementary school. Okay, so let's practice. Perform the following calculations, and we're going to round them to the correct number of significant figures. So in the first question, our first step is to line them up vertically where the decimals line up, keeping every place value directly underneath. Okay. Add those up. You can go ahead and put this into your calculator and get back 0.1656. Okay, now we're going to look at where the significance ends for each number and what decimal place that is. So in the first number, remember the zeros at the front are not significant. But starting at the 1, we go out to the 7, which is the thousandths place. Okay, in the second number, again, all of those zeros are placeholders starting out because they come before a non-zero digit. And so we only have 2 significant digits, and they go out to the 10,000ths place. And then the last number, again, only the 1 and the 2 are significant, and they stop at the thousandths place. So we're going to cut this off at whichever significance ends farthest to the left. Okay, so both that 7 in the first number and the 2 in the second are where the significance stops farthest to the left. And so that's where we have to cut it off at. So our last digit of significance is that 5 in our final answer. Look to the 6 and we're going to round it up so that our final answer is 0.166. Okay, and then the next example, we're going to do the same thing, line them up. Okay, again, making sure that those decimals or that ones place lines up with that second number. And 84.7593. Okay, again, in the calculator should come back to be 27,439. And then 0.7393. Okay, the first number goes out. All of those digits are significant, so it goes out to the 8, which is in the hundredths place. And then the second number, remember, we do not see a decimal in that second number. So any 0 after the last non-zero digit is not significant. And so my significance stops at that 4. Now the 0 is important for magnitude, but it is not considered significant. And then in the last number, all of those digits are significant. They're all non-zeros. Okay, so if we are looking at which number ends the farthest to the left in significance, it is our second number where the 4 is in the tens place. Okay, so we have to cut the significance before we even get to the ones place. Look to the right of the 3 and you get back 2, 7, 4, and then that 3 is going to round up to a 4. But we can't stop there because, as I've said before, sometimes zeros are important for magnitude. Okay, so you do have to keep the magnitude the same, which means that if we have 27,000, we should have it about 27,000 in our final answer. If I were to stop here and told someone that they had $2,744 in their bank account when they technically had 27,439, they would be very upset. Okay, so we've got to have the 2, 7, 4, 4, and we have to add any zeros back until we get to the ones place, which is here. Okay, so we have about 27,440, and it stops in significance at the 4, and the 0 is included for magnitude. So my final answer in the first part is 3 sig figs. And final answer for the second question would be 4 sig figs. Okay, so notice how the number of sig figs in my answer does not have to do with the number of sig figs that I used in the question, right? Because the least number of sig figs in the first question was technically 2. I had 0.0066 and 0.012. Those each had 2 significant figures. Okay, so that does not tell you how many sig figs you have in your answer. It's all based on that decimal place. Okay, so we're going to stop here, and in the next video, we're going to look at some examples that have multi-step calculations.